In the universe, there are colossal structures that contain entire galaxies. This audiobook invites you to explore galaxy clusters, invisible giants that hold the architecture of the cosmos. What secrets do these gravitational masses hide? And how can they help us understand the past and destiny of the universe? A journey through the hidden skeleton of space, where each galaxy is just a piece of something much larger. First of all, it's important to know what galaxy clusters are. Imagine a cosmic party where galaxies are the guests. Some of these parties are large and bustling, with many galaxies sharing the same space. Others are smaller and quieter, with only a few galaxies present. Essentially, a galaxy cluster is a group of galaxies that are bound together by gravity, forming a structure that can contain anywhere from dozens to thousands of galaxies. In this sense, they are like an exclusive club in the vast universe. The importance of galaxy clusters goes beyond their number. They are crucial for understanding how matter is organized in the universe, just as the buildings of a city group together to form an urban landscape. Galaxies group into clusters, and these clusters in turn group into even larger structures. However, what lies behind their formation? How are these cosmic megastructures created? The answer to this question is fascinating and reveals a story of collisions and mergers over billions of years. Galaxy clusters form from small groupings of matter that, as the universe expands, begin to attract more matter around them. It's as if a small magnet starts attracting iron filings, growing larger and larger. This accumulation of matter includes not only galaxies but also hot gas and dark matter, which plays a crucial role in the stability and evolution of the clusters. Speaking of dark matter, have you ever wondered what it is and why it is so important? Although we cannot see or touch it, dark matter is estimated to make up about 85% of the total mass of the universe. In the case of galaxy clusters, it acts as an invisible scaffold that keeps galaxies together and allows them to move and evolve. Without dark matter, galaxies would simply disperse. So, even though we don't see it, its influence is fundamental. As we explore galaxy clusters, it is essential to recognize that not all are the same. There are rich clusters which contain many galaxies and a large amount of matter, and poor clusters which have fewer galaxies and matter. Can you imagine a gathering where some groups are much larger than others? That is the dynamic we see in galaxy clusters. This diversity helps us better understand the different conditions that can exist in the universe. The galaxies within a cluster are not mere spectators. They interact with each other in surprising ways. Mergers and collisions are common events in these dense environments. Imagine two cars colliding at an intersection, and instead of stopping, they begin to merge and form a new vehicle. This is how galaxies can come together, creating new structures and sometimes giving rise to new stars in the process. The internal dynamics of clusters are another fascinating aspect. The galaxies are not stationary. They move at high speeds around the center of the cluster, like planets orbiting a star. This cosmic dance is driven by gravity, which acts as a conductor, guiding each galaxy in its path. Have you ever wondered how these galaxies move and what forces are at play? The answer lies in the interaction of gravity and dark matter, which creates a dynamic and exciting environment. Galaxy clusters are also places where new stars and stellar systems are formed. Just like a factory producing new units, clusters create the necessary conditions for stars to form from the gas and dust surrounding them. This means that within them, there can be a constant creation of new stars, enriching the universe with more light and energy. The evolution of the universe is profoundly influenced by galaxy clusters. As the universe expands, these cosmic colossi act as building blocks, shaping the large-scale structure. The study of these clusters helps us understand how the universe has changed over time and what the future holds. As we delve into the study of galaxy clusters, we are faced with a myriad of intriguing questions. How can we observe these giants from Earth? What technologies and methods are used to study them? And beyond astronomy, what implications do galaxy clusters have for our understanding of the universe and our own existence? The universe is a vast and enigmatic place, and galaxy clusters are one of the keys to unraveling its secrets. By understanding their formation, evolution, and interaction, we not only expand our knowledge of the cosmos, but also get a little closer to solving the mysteries that still remain in the dark. Galaxy clusters are undoubtedly a gateway to understanding the universe as a whole. Galactic clusters are true wonders of the universe, but what exactly are they? In simple terms, a galactic cluster is a vast group of galaxies held together by gravity, but this is not just any group of galaxies. These clusters can contain anywhere from a few dozen to thousands of galaxies, forming some of the largest and most complex structures in the cosmos. Can you imagine a city in space where each galaxy is like a building? And together they form an impressive ensemble that challenges our understanding of the universe. The composition of a galactic cluster is fascinating. In addition to the galaxies, these clusters are filled with hot gas, which often shines in X-rays, and a significant amount of dark matter, which we cannot see directly, but whose presence is essential for keeping the galaxies together. Think of dark matter as the invisible glue that holds the structure of this enormous ensemble. Without it, the galaxies would scatter as if there were nothing to bind them. The sizes of galactic clusters are also impressive. Some extend over millions of light years, meaning that the distance between galaxies within a cluster can be enormous. To put it into perspective, if we consider our galaxy, the Milky Way, as a small tree in a forest, a galactic cluster would be like a vast forest filled with trees of different shapes and sizes, all growing together in a complex ecosystem. Now, what is the importance of these clusters in the universe? Their existence offers us clues about the formation and evolution of galaxies. By studying galactic clusters, astronomers can better understand how galaxies group together and how they interact over time. This is like observing different groups of animals in nature. Each group has its own dynamics, interactions, and history. Let's imagine that galactic clusters are like large communities. Within these communities, each galaxy has its own role, just like the inhabitants of a neighborhood. Some galaxies may be larger and more dominant, while others are smaller and may be influenced by their neighbors. This type of interaction is key to understanding how galaxies develop over billions of years. Moreover, the way galactic clusters form is an incredible process. In the early universe, after the Big Bang, matter was grouped irregularly. Over time, these small concentrations of matter began to attract more material around them, forming the first clusters. Thus, gravity acts like a magnet, pulling galaxies and gas towards the center of the cluster. What about dark matter in this process? Dark matter is fundamental for the stability of galactic clusters. Without it, we could not explain why galaxies remain bound together. It's like building a house without a foundation. Without those solid foundations, everything would collapse. By understanding dark matter, scientists can unravel the secrets surrounding the formation and evolution of clusters. It is essential to recognize that not all galactic clusters are the same. There are rich clusters which contain many galaxies and a large amount of matter, and poor clusters which are less dense and have fewer galaxies. This classification helps us understand the diversity of the universe and how galaxies are organized in different environments. Galactic clusters are also places of intense activity. The galaxies within a cluster are not static. They interact, collide, and sometimes merge. These encounters can trigger the formation of new stars, adding even more complexity to life within a cluster. Thus, each cluster can be seen as a cosmic laboratory where large-scale experiments in galaxy and star formation are taking place. Have you ever thought about how galaxies move within a cluster? The dynamics of these movements are fascinating. Galaxies do not move through the cluster uniformly, rather they are in constant interaction, affected by the gravity of their companions. This gravitational dance can lead to impressive phenomena, such as the creation of elliptical galaxies from mergers. As we continue to explore galactic clusters, it becomes evident that their study is crucial for understanding the history of the universe. Each cluster is like a time capsule, containing clues about the events that have shaped our cosmos. From the formation of the first galaxies to the evolution of more complex structures, clusters tell us a deep and rich story. In summary, Galactic clusters are much more than simple groupings of galaxies. They are dynamic environments full of mysteries and opportunities for the formation of new stars, and they are fundamental to understanding the structure of the universe. By exploring their composition, formation, and dynamics, we delve into the deepest secrets of the cosmos and the very history of our existence. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey. The formation of galaxy clusters is a fascinating process that can be compared to the creation of a vast and complex ecosystem on Earth. Imagine a large lake surrounded by mountains where the currents of water bring nutrients and life. In the universe, this lake is the empty space, and the currents are the gravitational forces that attract galaxies and dark matter toward a common point. But how does this process begin? First, it is essential to understand that the universe has not always been as we know it today. In the beginning, everything was filled with a mix of subatomic particles floating in a sea of energy. Over time, these particles began to group together, forming clouds of gas and dust. As these clouds cooled, gravity began to play its role, attracting more and more material toward them. This is how the first stars are born, but this is where the story becomes even more intriguing. When several stars are born in the same region of space, they start to influence each other through gravity. It's as if they are engaged in a cosmic dance, where each star pulls the others toward its center. In this process, some of these stars may form small galaxies. But what happens when those small galaxies meet? The answer is that they can merge, creating larger structures. This phenomenon is what gives rise to galaxy clusters. The merging of galaxies is just one part of the process. As these structures grow, gravity continues to pull more galaxies and dark matter toward them. It is a continuous cycle, where each new addition makes the cluster more massive and complex. Think of it as a magnet attracting metallic elements. Each time a new component is added, the magnet becomes stronger and capable of attracting even more. The formation of clusters is also influenced by the expansion of the universe. As space expands, some regions become denser, meaning that gravity in those areas is stronger. In those dense zones, matter groups together more quickly, facilitating the formation of galaxy clusters. This creates a delicate interplay between the expansion of the universe and gravitational attraction, where both forces act in a cosmic dance. One fascinating aspect is the role of dark matter in this formation. Although we cannot see dark matter, we know it is present due to its gravitational influence. It acts as an invisible skeleton that holds galaxy clusters together, providing the necessary structure for galaxies to group and remain united. Without this mysterious matter, galaxy clusters would not exist as we know them. Galaxy clusters can also vary in size and density. Some are rich in galaxies and matter, while others are more dispersed and contain fewer galaxies. This variability is due to the formation history of each cluster, which is often marked by unique events such as galactic mergers or interactions with other clusters. Each cluster has its own narrative, a tale of its growth and evolution over cosmic time. The influence of galaxy clusters does not stop at their own formation. Once established, they can affect the environment around them. For example, they can attract other clusters, creating even larger superclusters, demonstrating that gravity has an impact on scales much larger than we might imagine. This leads us to understand that in the universe, everything is interconnected. Clusters are part of a constantly evolving cosmic network. Have you ever wondered how these galaxy cluster formation processes influence the evolution of individual galaxies? As galaxies group into clusters, their interaction can lead to the formation of new stars and stellar systems, thus enriching the universe with more elements and diversity. The life cycle of a galaxy is intertwined with the life cycle of clusters, showing that each depends on the other for its existence. In the end, the formation of galaxy clusters is a testament to the power of gravity and the cosmic forces that shape our universe. Each cluster is an example of how matter can organize itself into complex structures from initial chaos. As we continue to explore the cosmos, each discovery about galaxy clusters brings us a little closer to understanding our place in the universe and the history we share with these majestic structures. Human curiosity drives us to inquire more about these cosmic giants. Each new investigation opens doors to deeper questions and challenges us to keep seeking answers. Galaxy clusters are not just an astronomical phenomenon. They are a mirror in which we reflect our own quest for knowledge and understanding of the universe around us. In each cluster, there is a story waiting to be told, and in each story, there is a piece of ourselves. What really holds galaxies together in those enormous clusters we observe in the universe? The answer lies in a fascinating and mysterious concept: dark matter. To understand its importance, we must first imagine a scenario where the universe is a vast ocean. In this ocean, galaxies are like floating islands, visible and beautiful, but what keeps them united in a cluster is something we cannot see, feel, or touch: dark matter. Dark matter is a type of matter that does not emit light or energy, making it invisible and extremely difficult to detect. But how do we know it exists? Scientists have reached this conclusion by observing the movement of galaxies within clusters. When we analyze how these galactic islands move, we notice that they behave in a way that cannot be explained solely by visible matter. It's as if the islands float in a sea of something we cannot see, but which exerts an impressive gravitational force. Imagine a group of friends playing soccer on a field. If everyone is running and making plays, but there is an invisible force that keeps them together, that is similar to what happens in a galactic cluster. Dark matter acts like a coach who, although not visible, has a huge impact on how galaxies move and organize themselves. Without this dark matter, galaxies would disperse like leaves in the wind, unable to form those majestic clusters. One of the most intriguing questions is, where does dark matter come from? Although we do not have definitive answers, scientists have proposed several theories. Some suggest it could be composed of exotic particles that we have never detected, while others talk about the possibility of some type of dark energy influencing dark matter. The quest to discover the nature of dark matter resembles an exciting cosmic treasure hunt, where each clue brings us closer to understanding the secrets of the universe. Dark matter is not only crucial in the formation of galactic clusters, but it also plays a vital role in their evolution. As the universe expands, dark matter acts as a cosmic skeleton guiding the growth of the universe's structures. Without this invisible network, galactic clusters could not acquire the mass and shape we observe today. It's a bit like an architect who, without being seen, designs the structure of a building. It is also interesting to consider how dark matter influences the interaction between galaxies within a cluster. When two galaxies approach each other, dark matter can act as a buffer, affecting gravity and altering their trajectory. This can lead to galactic mergers, where two galaxies come together to form a new entity. Similar to how two rivers can merge into one, these mergers are fundamental to the evolution of galaxies and at the same time to the formation of new stars. But why is it so difficult to detect dark matter? The answer lies in its very nature. By not interacting with light in the way normal matter does, we cannot observe it directly. This absence of interaction is like trying to see air. We know it's there because we feel its presence, but we cannot see it. Scientists are working on multiple approaches, from experiments in underground laboratories to observations of distant galaxies, to try to unravel this enigma. Furthermore, dark matter has a distribution that resembles a cosmic web. Instead of being evenly distributed, it concentrates in certain areas, forming what are known as dark matter halos around galactic clusters. These halos are essential for understanding how galaxies group together and how they evolve over time. Imagine a large magnet that attracts galaxies towards it, creating a cosmic dance that shapes the structure of the universe. Galactic clusters are, therefore, natural laboratories where the effects of dark matter can be studied. Every observation we make provides us with clues about its functioning and its role in the history of the cosmos. The relationship between dark matter and galactic clusters is one of the many pieces of the puzzle that astronomers seek to solve. As we advance in our understanding, we also face more complex questions. What if dark matter is not what we think? Could there be forms of matter or energy that we have not yet discovered? Every answer we find generates new questions, fueling our curiosity and our desire to explore beyond the known. The search for dark matter is a journey that takes us to the farthest reaches of the universe and at the same time to the limits of our understanding. In each galactic cluster, there is a story to tell. A story intertwined with dark matter and the evolution of the cosmos. As we continue to explore these themes, we get a little closer to unraveling the mysteries that have fascinated humanity for centuries. In summary, dark matter is an essential part of the structure of the universe. Without its influence, galactic clusters would not exist as we know them. It is the invisible thread that binds galaxies together and guides their evolution over time. Thus, every time we look up at the night sky and contemplate the stars, we should remember that there is much more than what we can see, and that dark matter remains one of the great mysteries of modern astronomy. Galactic clusters are like large neighborhoods in the vast universe where galaxies live, interact, and evolve together. But did you know that not all galactic clusters are the same? There are different types, each with its own characteristics and peculiarities. I invite you to discover the fascinating classification of these giants of the cosmos. First, let's talk about rich clusters. Imagine a party where everyone is invited. But in this case, the guests are a large number of galaxies. Rich clusters are those that contain a large number of galaxies, often more than 100. They are like a bustling shopping mall full of activity, where galaxies move and interact with each other. These clusters are very important for astronomers, as their high density makes them easier to study. On the other hand, we have poor clusters. Think of a small cafe on a quiet street, where only a few people are enjoying their coffee. That's what poor clusters are like, having fewer galaxies, generally less than 30, although they may seem less impressive than their rich cousins. These clusters are also essential for understanding the diversity of cosmic structure. They teach us that the universe is not just a place of large gatherings, but also has more solitary and dispersed areas. Apart from the number of galaxies, clusters also differ by their composition. Some clusters are primarily composed of elliptical galaxies, while others mostly contain spiral galaxies. Elliptical galaxies are like old sages, with a rounded shape and a calmer appearance. In contrast, spiral galaxies are younger and more active, with arms extending in a beautiful and dynamic design. This mix of galaxy types in a cluster can give us clues about its history and how they have interacted over time. Galactic clusters are not only a home for galaxies, but they also host a large amount of dark matter. Imagine that at a party, most of the energy is not in what is seen, but in what is unseen, like the background music. Dark matter acts like that music, influencing how galaxies move and how clusters are structured, even though we cannot see it directly. This dark matter is essential for maintaining the cohesion of the clusters, acting as an invisible glue that binds galaxies together. A fascinating aspect of galactic clusters is their evolution. Over time, clusters can change categories. A poor cluster can attract more galaxies and transform into a rich cluster. This process is like a small business expanding and attracting more customers. As galaxies come together, new stars and new dynamics can form within the cluster. So clusters are not static entities. They are in constant change and evolution. The way galaxies group within a cluster is also interesting. Some galaxies may be closer to each other, while others may be more distant. This can create a variety of interactions, from galaxy mergers to close encounters, where they influence each other without merging. These interactions are essential for the evolution of galaxies, as they can trigger new star formations and alter the structure of these galaxies. Galactic clusters can also be classified according to their structure. Some have a more uniform distribution, while others show a clear hierarchy, with large galaxies dominating the smaller ones. This phenomenon resembles a chain of mountains, where some peaks are higher and more prominent than others, creating a diverse and rich cosmic landscape. But how do these galactic clusters form? Mostly they form through gravity. small groupings of galaxies can attract others over billions of years, creating a larger cluster. This process is similar to how a snowball grows larger as it rolls down a slope, accumulating more and more snow along the way. Gravity acts as the engine behind this accumulation, pulling more galaxies toward the center of the cluster. As we explore these clusters further, we also find that some are extraordinarily ancient. Some clusters may have existed since almost the beginning of the universe, acting as time capsules that provide us with information about the history of the cosmos. They are like ancient monuments that speak to us of past eras, allowing us to understand how the universe has changed over billions of years. It is fascinating to think that in these galactic clusters, life itself could be at stake. The presence of different types of galaxies and the interactions that occur between them can influence the formation of new stars and potentially the creation of planetary systems where life could arise. Thus, galactic clusters are not only important from a cosmic perspective, but they may also have implications for our own existence. Finally, we cannot forget that galactic clusters are an active field of study for astronomers. With each new observation, we learn more about how they form, evolve, and break apart. As technology advances, our telescopes become more powerful and capable of seeing beyond what we once thought possible. Each discovery brings us closer to understanding the mysteries of the universe and our place in it. So the next time you look up at the starry sky, remember that behind each point of light there could be a galaxy and a galactic cluster, forming part of a much larger cosmic story. These giants of the universe are indeed the very fabric of cosmic structure, uniting galaxies, stars, and potentially life in a vast and beautiful cosmic stage. Galaxies within a galaxy cluster are not just cosmic companions, they maintain a dynamic and exciting relationship. But how do these vast cities of stars actually interact? Imagine a grand dance where each galaxy is a partner moving in a cosmic choreography, with some coming closer, others drifting apart, and some merging in a fascinating display of light and matter. Interactions between galaxies can range from friendly encounters to dramatic collisions. When two galaxies approach each other, they begin to feel each other's gravitational pull, as if they were magnets. This tug can alter their trajectories and, in some cases, cause their shapes to intertwine, creating an impressive visual spectacle. Can you imagine what it would be like to see two galaxies dancing together in space, their spiral arms entwining in a cosmic embrace? A fascinating phenomenon is that of galactic mergers. These occur when two galaxies meet head-on and combine, forming a single larger entity. During this process, not only do the stars merge, but the gas and dust also come together to form new stars in a spectacle of creation. Have you ever wondered what happens to the stars that were in the path of this collision? Some may be thrown into new orbits, while others may be absorbed by the new galaxy. Imagine a cosmic game of billiards, where each star is a ball that can change its fate in an instant. Interactions are not always so dramatic. Some galaxies may simply pass close to one another in what is known as close encounters. During these encounters, the effects of gravity can lead to the formation of new structures such as spiral arms or even a new generation of stars. These encounters are like conversations between friends that can lead to new ideas and changes. Who would have thought that a simple gravitational brush could give rise to new stars? Now, what role does dark matter play in these interactions? Dark matter, that mysterious substance we cannot see but know is there, affects the gravity of galaxies and therefore their interactions. It serves as an invisible framework that guides and controls the movement of galaxies, as if it were the conductor of this grand cosmic ballet. Without it, the behavior of galaxies would be very different. Can you imagine a dance without music, where the dancers don't know when to move? Interactions between galaxies can also impact star formation. When gas is compressed during a collision or a close encounter, it can trigger the creation of new stars. This process is similar to how a dense cloud can produce rain when compressed. Thus, each collision or close encounter can be an opportunity for new stars to be born and shine in the vast universe. An interesting aspect of these interactions is the role of galaxy clusters as nurseries for new galaxies. When a cluster forms, the galaxies within it begin to interact and merge, which can lead to the creation of new galaxies. It's like a cosmic farm where, from the mixing of different species, new forms of life emerge. Each new cluster that forms is an opportunity for a new galactic story to begin. However, not all interactions are constructive. Sometimes galaxies can be destroyed or stripped of their components during these collisions. It serves as a reminder that the universe is both a place of creation and destruction, a constant cycle of life and death. Can you imagine the fate of a galaxy that, caught in the gravity of a more massive one, is torn apart and transformed? Galactic interactions can also influence the evolution of individual galaxies. A galaxy within a cluster may experience significant changes in its structure and composition due to its encounters with other galaxies. This change can be so drastic that, over time, the galaxy may become something entirely different. Have you ever wondered how many galaxies have changed their shape and destiny due to a fortunate or unfortunate encounter? Observations of these galactic interactions have provided astronomers with a window into the past of the universe. By studying galaxies that have undergone mergers or close encounters, we can learn about how galaxies were in the past and how they have evolved over time. It's like unearthing an ancient book of cosmic history, where each page reveals a chapter about the life and interactions of galaxies. Today, astronomers use powerful telescopes and computer simulations to study these interactions up close. These technological advancements allow us to observe galaxies that are millions of light years away and better understand how they behave in the context of a cluster. It's an exciting journey through time and space, where each discovery is another step toward understanding the universe. Interactions between galaxies also make us reflect on our place in the cosmos. We are part of a constantly changing universe where every star and every galaxy is connected in some way. Just as galaxies interact and evolve, we, as humanity, also have the capacity to learn, adapt, and grow from our own interactions. Isn't it amazing to think that amidst this vast immensity, we all are part of the same grand cosmic narrative? In summary, interactions between galaxies within a galaxy cluster are a cosmic dance full of complexities and surprises. From dramatic mergers to subtle encounters, each interaction has the potential to influence the formation and evolution of galaxies. They show us that the universe is in a state of constant transformation and that, just like galaxies, we too are on a journey of discovery, learning, and growth. The dynamics of galaxy clusters is a fascinating cosmic dance that reveals much about the behavior of galaxies within these vast groupings. Have you ever wondered how galaxies move within these enormous assemblages? The answer is somewhat surprising, as it resembles a large spa where each galaxy is like a person enjoying the waves at the beach, moving in response to the forces around them. Galaxy clusters are extraordinarily large, composed of hundreds or even thousands of galaxies. Imagine a gigantic field of flowers where each flower represents a galaxy. However, not all the flowers are static. Some move forward, others backward, and some even seem to be spinning. This movement is driven by gravity, the force that holds the galaxies together within the cluster, as if they were a group of friends holding hands while moving together. Gravity plays a fundamental role in the dynamics of clusters. When two galaxies meet, they enter a game of gravitational attraction that can lead them to merge. Think of two dancers approaching each other on the dance floor. At first, they keep a certain distance, but as they feel drawn to each other, they begin to spin and dance together, creating a new movement on the floor. This dance can lead to the formation of new stars, which emerge from the remnants of these galactic collisions. However, not all interactions are so romantic. Sometimes galaxies can experience more violent encounters. These collisions can strip a galaxy of its gas and dust, the essential ingredients for forming new stars. In this sense, galaxies can be like a group of children playing with a balloon. If they squeeze it too hard, they might make it burst. Thus, galaxies, while moving together, are also at risk of losing their essence in the process. An intriguing aspect of the dynamics of galaxy clusters is how the speed of galaxies varies within these enormous assemblages. Some galaxies move quickly, like a marathon runner, while others move more slowly, like a carefree walker. This diversity in speed is due to the influence of the cluster's gravity, which acts as a master of ceremonies in this cosmic dance. Galaxies closer to the center of the cluster tend to move faster, as they are more subject to gravitational attraction. At the center of a cluster, galaxies can experience a fascinating phenomenon, the formation of a supermassive black hole. This colossal object can influence the movement of nearby galaxies, like a magnet attracting small metal fragments. This black hole not only affects the galaxies, but can also alter the flow of gas and dust in the cluster, creating a domino effect that reverberates throughout the environment. As galaxies move, they also generate shock waves in the intergalactic medium, a kind of sound that resonates throughout the cluster. These waves can heat the surrounding gas, which in turn affects the formation of new stars. Imagine you are at a concert. When the music becomes more intense, the atmosphere changes and can make everyone in the room feel more excited. Similarly, the movement of galaxies in a cluster can energize the intergalactic medium. The structure and behavior of galaxy clusters are complex and multifaceted. Computer simulations have allowed astronomers to model how galaxies behave within these groups. These simulations are like a video game where players can observe how galaxies interact, providing a clearer insight into the patterns that form in the dynamics of the cluster. However, not everything can be explained with simulations. There are mysteries that remain to be solved, such as the influence of dark matter on the dynamics of clusters. This invisible matter can affect how galaxies move, even though it cannot be seen directly. Imagine being in a dark room and feeling the pressure of the wind. You know something is there, but you can't see it. This is how astronomers try to understand dark matter, through its effects on the movement of galaxies. Interactions between galaxies can also lead to unexpected phenomena. For example, in some clusters, cannibal galaxies have been observed devouring smaller galaxies, a process that can drastically change the structure of the cluster. This behavior is similar to when a group of friends joins a party and some end up hogging the attention while others are relegated to the background. Ultimately, galaxy clusters are cosmic laboratories where the forces that have shaped the universe since its inception can be studied. The way galaxies move and relate to each other offers us clues about the history and evolution of the cosmos. Each galaxy, each collision, and each merger are chapters of a monumental story unfolding in the vast fabric of the universe. So as we explore the dynamics of galaxy clusters, we are not just observing an amazing spectacle of movement and light. We are unraveling the secrets of how our universe was formed and how it will continue to evolve in the future. In this immense ocean of stars and galaxies, every movement tells a story, and each galaxy cluster is a page in the cosmic book of existence. The formation of new stars and stellar systems within galaxy clusters is a fascinating process that reveals how the universe is constantly transforming. But what really happens in these vast spaces filled with galaxies? In galaxy clusters, gas and cosmic dust play a crucial role, acting as the basic ingredients for the creation of new stars. This gas, known as molecular hydrogen, is the material from which stars are formed. However, it is not just a simple accumulation process. There is a cosmic dance at play that is vital for the evolution of these stars. When galaxies within a galaxy cluster come close to each other, they generate gravitational forces that can compress the gas. Imagine a group of friends at a party gathering in a corner. As they get closer, the energy of the conversation increases and excitement grows. In the universe, that same energy translates into heat and pressure, causing the gas to condense and eventually collapse to form stars. But what happens if these stars form in such a crowded environment? The competition is fierce. In a galaxy cluster, stars are not the only ones seeking to grow. Gravitational interactions with other galaxies can alter the trajectories of the gas, causing a new star to form in an unexpected location. Just like in a relay race, the baton can change hands in surprising ways. This means that star formation is not a linear process, but one filled with surprises and unexpected twists. As new stars form, what happens to the old ones, the most massive stars at the end of their lives? Explode in spectacular supernovae. This event is not just a visual spectacle, it is also a generator of new materials. The heavy elements created during these explosions are scattered throughout the cluster, enriching the interstellar medium and providing the necessary ingredients to form new stars and planets. This life cycle of stars sounds like a story of continuous renewal, where the death of one star gives life to others. An intriguing aspect is the role that galaxy clusters play in star formation. In denser regions of the cluster, where matter is concentrated, star formation can be more active. Here, gas and dust clump together, and the gravitational influence of nearby galaxies can attract more material to these hotspots. The result is an environment conducive to the creation of new stars on a scale much larger than we might imagine. However, not everything is perfect in this whirlwind of star creation. The intense radiation from newly formed stars can heat the surrounding gas, causing it to disperse before it has the chance to become new stars. It's like a group of students in a library starting to talk too loudly. The noise can scare others away and make it difficult to concentrate. This delicate balance between star formation and the forces that destabilize it is a key topic in modern astrophysics. Another factor to consider is the phenomenon of star cluster formation. These are groups of stars that form together from the same gas cloud. In a galaxy cluster, pressure and gravity can cause these gas clouds to collapse jointly, creating groups of stars that share a common history. It's a bit like forming a music band. Each member has a unique role, but together they create a harmony that is greater than the sum of its parts. Interactions between galaxies also play a significant role in star formation. When two galaxies collide, their gases can be dramatically unleashed, generating waves of star formation. This spectacle of lights and colors in the night sky is the result of cosmic forces at work, demonstrating that sometimes collision does not only lead to destruction, but also gives rise to new beginnings. The study of galaxy clusters also offers us a window into the past and future of the universe. By observing how stars form and evolve in these environments, astronomers can gain insights into how the structure of the cosmos will develop. Each star that forms is like a page in a cosmic history book. And by reading these pages, we can better understand our place in the universe. As we reflect on the relationship between galaxy clusters and star formation, it is undeniable that these cosmic giants are the stage for an extraordinary life story. As stars are born, shine, and eventually die, the cycle of life continues. And in this cycle, each star has the potential to host planets, some of which may be capable of supporting life. The connection between galaxy clusters and star formation is a reminder of the complexity and beauty of the universe. It shows us that even in the empty space, there is vibrant and dynamic activity that leads to the creation of new generations of stars and potentially life. In this vast cosmic theatre, each star is an actor, and each galaxy cluster is a stage where the grandest stories of creation are performed. Galactic clusters are like enormous cities in the vast ocean of the universe, and their role in the evolution of the cosmos is crucial. But how do these giants influence the overall structure of the universe? To understand this, we must first immerse ourselves in the idea that everything in the cosmos is interconnected. Each galactic cluster acts as a brick in the construction of the grand structure of the universe, forming a complex network that shapes what we see today. Galactic clusters not only group galaxies, but are also essential in the way matter is distributed throughout the universe. Have you ever wondered how a galaxy forms? The answer lies in the clusters. The gravity of these colossi attracts gas and dust, creating the perfect conditions for new stars to form. Thus, each cluster becomes an incubator for stars where cosmic life begins to flourish. The influence of galactic clusters goes beyond their own existence. They have been found to affect the movement of nearby galaxies, influencing their trajectories and how they group in space. This phenomenon is comparable to how a large mass of land can change the course of a river. In this way, galactic clusters act as gravitational guides, shaping the fate of the galaxies that surround them. But what about dark matter, this mysterious element which constitutes most of the universe's mass? Plays a fundamental role in galactic clusters. Without it, these giants could not exist. Dark matter acts as an invisible scaffold, holding galaxies in place and allowing clusters to form. Without this ethereal substance, the cosmos would be a very different place, with lonely and isolated galaxies instead of the magnificent clusters we observe. As galactic clusters evolve, so do the galaxies within them. The interactions between these galaxies can be intense, leading to spectacular mergers that give rise to new structures. Imagine two galaxies as two cars meeting on a road. Their collision not only changes their trajectory, but also transforms their shape and composition. Thus, each encounter between galaxies can trigger the creation of new stars and systems, further enriching the fabric of the universe. Clusters also bear witness to the history of the universe. By observing their formation and evolution, scientists can unravel the secrets of the cosmos's expansion. What do these colossi tell us about the past? Through their study, we can better understand what the universe was like in its early stages and how it has come to be what we know today. Each cluster is a time capsule containing clues about the events that shaped our cosmic home. Another fascinating aspect is how galactic clusters interact with the intergalactic medium. The energy and dynamics that occur within them can influence the gas and dust surrounding them, contributing to the formation of new galaxies. This process is similar to how a plant can affect the soil around it, enriching the ground for future generations. Thus, clusters are not only important for themselves, but also nourish the growth of new structures in the universe. The relationship between galactic clusters and star formation is another intriguing phenomenon. Clusters act as cosmic factories where gas condenses and gives rise to new stars. The activity within a cluster can be likened to a farm, where the right conditions allow new lives to emerge. Without these favorable environments, many stars would not have the opportunity to be born. However, the fate of galactic clusters is not set in stone. As the universe expands, these colossi are also destined to change. Some will merge with others, creating even larger structures, while others will disperse as dark matter separates them in this cosmic dance. Each cluster has a role to play in the ongoing evolution of the universe. In the context of cosmology, galactic clusters are essential for understanding how the cosmos has evolved since its origin. They help us answer fundamental questions about the nature of the universe, its expansion, and its components. What does this mean for our own existence? It reminds us that we are part of a larger whole, interconnected with every star and every galaxy in the vast universe. As we explore more about galactic clusters, we discover that they are not just inert structures. They are dynamic, changing, and full of life. Each cluster tells a story that teaches us about the past and future of the universe. Through them, we can begin to glimpse how the cosmos was formed and where it is headed. The importance of galactic clusters in the evolution of the universe is undeniable. They are not only the architects of cosmic structure, but also the guardians of the secrets of time. By studying them, we come one step closer to understanding our place in this immense and wonderful universe. So the next time you look at the starry sky, remember that each spark of light is a galaxy. And behind each galaxy, there may be a cluster, playing its role in the grand work of the universe. The exploration of galactic clusters not only enriches our understanding of the cosmos, but also connects us with the very essence of existence. Isn't it fascinating to think about everything at stake in this vast network of galaxies and clusters? How can we observe something that is so far away that its light has taken millions of years to reach us? This is one of the most fascinating questions when we talk about galaxy clusters. The answer lies in the combination of human ingenuity and advanced technology. With telescopes and space satellites, we have the ability to look back in time and explore these gigantic groupings of galaxies. The methods of observation are diverse, and each contributes a piece to the puzzle of the universe. For example, optical telescopes, which work similarly to our eyes, allow us to see the visible light emitted by stars and galaxies. However, the universe is not limited to what our eyes can capture. There is much more at play. And this is where other types of telescopes come into action. Imagine the universe as a vast and dark ocean. While optical telescopes are like fishing boats on the surface, X-ray and radio telescopes are like submarines that dive into the depths, revealing hidden worlds. X-ray telescopes, for example, are essential for studying the hot matter found in galaxy clusters, matter that emits radiation in wavelengths we cannot see with the naked eye. Some of the most intriguing structures within galaxy clusters are the halos of hot gas. How can we detect them? This is where X-ray technology proves its worth. When electrons in this hot gas interact with radiation, they emit X-rays that can be captured by our telescopes. This allows us to study not only the composition of the clusters, but also their temperature and density. In addition to X-rays, radio telescopes play a crucial role. These telescopes can capture the radio waves emitted by certain galaxies and their interactions. Have you ever wondered how galaxies communicate with each other? Through these waves, we can gain insights into the interactions and mergers occurring at the heart of galaxy clusters. We cannot forget the importance of space telescopes. By being above the Earth's atmosphere, they can capture light spectra that other telescopes cannot. This translates into more precise and detailed data about the chemical composition of galaxy clusters. Thanks to these telescopes, we have been able to identify elements such as hydrogen, helium, and other compounds that form the fabric of these enormous structures. The observation of galaxy clusters also benefits from international collaboration. Projects like the Hubble Space Telescope, which has been in orbit since 1994, have provided stunning images that have changed our understanding of the cosmos. Technology is advancing rapidly, and thanks to next-generation telescopes like the James Webb Space Telescope, we are on the verge of discovering more about the history and evolution of these galactic giants. But what about simulation? Sometimes scientists cannot directly observe certain events, and this is where computational models come in. These models allow astronomers to simulate the evolution of galaxy clusters over time. Imagine creating a video game of the universe where you can control the interactions between galaxies and observe how they behave in different scenarios. This helps us better understand the behavior of clusters and make predictions about their future. Light is not the only form of information we receive from space. Cosmic background radiation, considered an echo of the Big Bang, also provides us with valuable data about the distribution of matter in the universe. By analyzing how this radiation interacts with galaxy clusters, scientists can gain clues about the amount of dark matter present and how it affects the structure of the cosmos. As technology continues to advance, so does our ability to observe galaxy clusters. New telescopes are on the way, and each promises to open new windows to the universe. What discoveries await us, only time will tell. However, one thing is certain: each advance in observation brings us a little closer to answering fundamental questions about the formation, evolution, and fate of these galactic colossi. The observation of galaxy clusters is an exciting journey that combines human curiosity with science. Each captured image and each analyzed piece of data are steps toward a deeper understanding of the universe we live in. So as we continue to look toward the stars, let us remember that each observed galaxy cluster is a testament to our desire to explore the unknown and unravel the secrets of the cosmos. Galactic clusters are like large cities in the vast ocean of the universe, but what role do they play in understanding modern cosmology? This question leads us to explore the importance of these colossi in the structure of the cosmos and their relationship with the expansion of the universe. Just like cities on Earth, galactic clusters show us how galaxies group together and interact with each other, providing clues about the history and fate of the universe. First, it is essential to understand that galactic clusters act as the largest structures in the cosmos. Imagine a network of roads connecting different cities. Galactic clusters are those intersections where galaxies group together, creating a complex network that reveals how matter is distributed in the universe. Without these groupings, it would be difficult to comprehend how the cosmos formed and how it has expanded over billions of years. The diversity of galactic clusters is also fascinating. There are rich clusters, which are dense and contain hundreds or thousands of galaxies, and poor clusters, which have only a few. This variability not only tells us about the formation of galaxies, but also reflects the history of the universe itself. Each cluster is like a book that narrates a unique story about space and time. By observing galactic clusters, astronomers can measure the distribution of matter in the universe. Why is this so important? Because dark matter, which is invisible and does not emit light, plays a crucial role in the gravity that holds galaxies together in these clusters. Without a proper understanding of dark matter and its influence, it would be like trying to assemble a puzzle without having all the pieces. When we talk about the expansion of the universe, galactic clusters are essential for understanding how the cosmos has behaved over time. By studying their distribution, scientists can determine whether the universe is expanding, contracting, or if it will remain in equilibrium. This knowledge helps us answer profound questions about the ultimate fate of the universe. Will it fade into a cold void, or will it collapse into a big crunch? Moreover, galactic clusters act as natural laboratories where the effects of gravity and dark matter can be observed. When galaxies within a cluster interact and collide, they release energy and create new stars. This process is similar to a manufacturing workshop, where new pieces are created from recycled materials. Thus, galactic clusters are not only places of aggregation but also of creation. Research on galactic clusters has also led to new discoveries about the acceleration of the universe's expansion. Dark energy is a fascinating concept that has emerged in this context. Like a mysterious force pushing outward, dark energy seems to be accelerating the expansion of the universe. Galactic clusters are crucial for understanding how this dark energy interacts with visible matter. Furthermore, by studying galactic clusters, scientists can investigate the conditions of the universe in its youth. By observing clusters that formed billions of years ago, information can be obtained about what the early galaxies were like and how they evolved over time. This is a window into the past that allows us to reconstruct the history of the universe. So, what is the connection between galactic clusters and life in the universe? By understanding how they formed and evolved, we can get an idea of how stellar systems are distributed and therefore the possibilities of life in those systems. Could other galactic clusters harbor worlds like ours? Research on galactic clusters does not stop. New technologies and telescopes are expanding our capabilities to observe and study these colossi. Right now, there are space missions and telescopes on Earth dedicated to unraveling the mysteries of galactic clusters, seeking to answer questions that are still open. The importance of galactic clusters in modern cosmology cannot be underestimated. They help us understand not only the structure of the universe but also its evolution and fate. Each discovery about these groupings brings us one step closer to understanding the enigma of the cosmos. Finally, upon reflecting on galactic clusters, it becomes evident that they are more than just a collection of galaxies. They are true maps of the universe, guiding us in our quest for answers to fundamental questions about our place in the cosmos. Their study is essential for understanding the history of the universe and the role we play in it. With each discovery, a new chapter unfolds in the cosmic story, inviting us to continue exploring and learning about the vastness that surrounds us. Galaxy clusters are not just large groupings of galaxies. Within them, they also harbor some of the most fascinating phenomena in the universe. What happens when a galaxy encounters a supermassive black hole? The answer to this question leads us to a world where gravity and energy intertwine in surprising ways. Most galaxy clusters contain a supermassive black hole at their center, which can be millions or even billions of times heavier than our own sun. But what does this mean for the surrounding galaxies? Imagine a huge whirlpool in a river where the currents of water move in opposite directions. In a galaxy cluster, the black hole acts as the core of this whirlpool, influencing the movement of the galaxies around it. Galaxies do not just orbit this black hole, they can also be drawn toward it, which can lead to dramatic interactions. Sometimes these galaxies, when they get too close, can be torn apart by the intense gravitational force, becoming a cosmic spectacle worthy of admiration. The way supermassive black holes affect their cluster is a topic that has intrigued astronomers for decades. As galaxies fall into the gravitational trap of the black hole, they release enormous amounts of energy. Can you imagine what happens when a galaxy gets so close to a black hole that it begins to be devoured? This action can trigger jets of particles and radiation that shoot out at speeds close to the speed of light, creating brilliant phenomena that can be observed even billions of light years away. However, the influence of black holes is not limited to the energy they emit. They can also affect the formation of new stars within the galaxies of the cluster. When a supermassive black hole is active, its energy can heat the surrounding gas and dust, preventing it from cooling and collapsing to form new stars. This balance between creation and destruction is a fascinating aspect of the dynamics of galaxy clusters. As researchers delve deeper into the study of galaxy clusters and their supermassive black holes, an intriguing question arises. How do these giants form in the first place? They are believed to form from the merger of smaller black holes, which in turn originate from the collapse of massive stars. This process is a constantly evolving cosmic ecosystem where interactions between galaxies and black holes can lead to new phenomena. One of the most notable features of supermassive black holes is their ability to influence the galaxies in their cluster, not only through gravity but also through processes that release energy. This creates an environment where hot gas becomes a medium for galaxy formation. The relationship between black holes and galaxies is, in a sense, a cosmic dance where each affects the other in an eternal ballet that has been occurring since the beginning of time. Recent observations have revealed that not all galaxy clusters have supermassive black holes at their center, and the question of why some do and others do not remains unanswered. This variability raises even more questions about the evolution of large-scale structures in the universe. Could it be that the presence of a supermassive black hole is an indicator of how a particular galaxy cluster formed and evolved? In many cases, supermassive black holes can act as catalysts for galactic evolution. As galaxies merge and approach these giants, the result can be a more dynamic and diverse cluster. Some galaxy clusters, such as the famous Virgo cluster, have been found to contain supermassive black holes that directly influence the star formation rate of their member galaxies, demonstrating the intrinsic connection between these phenomena. The exploration of galaxy clusters and their supermassive black holes also leads us to reflect on the role of dark matter. Although we cannot see dark matter, we know it is there, acting as the invisible skeleton that holds galaxies and clusters in place. Supermassive black holes surrounded by dark matter may be part of a much more complex system that we are still trying to unravel. Furthermore, the study of these black holes and their behavior in galaxy clusters has implications for our understanding of the universe itself. By examining how these giants interact with their environment, we can gain insights into the expansion of the universe and the formation of large-scale structures. The quest for answers to these questions is an exciting journey, where each discovery can open new doors to knowledge. The role of supermassive black holes in galaxy clusters is an active area of study. Technological advancements in telescopes and observatories have allowed astronomers to observe these phenomena with unprecedented detail. Every time we capture an image of a supermassive black hole in action, we are one step closer to understanding the complexity of the cosmos and our place within it. The connection between supermassive black holes and galaxy clusters is not only fascinating from a scientific perspective, but also invites us to contemplate our own existence. These cosmic giants remind us of the vastness of the universe and the processes that have shaped the reality we know. Each supermassive black hole is a testament to the history of the cosmos, a beacon guiding us in our quest for answers about the universe and our place in it. In conclusion, supermassive black holes in galaxy clusters are more than just mysterious entities. They are keys to unraveling many of the secrets of the universe. As we continue to investigate and explore, each discovery about their nature and behavior brings us a little closer to understanding the vast and enigmatic web that constitutes our cosmos. Galactic clusters in the early universe are a fascinating puzzle that astronomers have been trying to solve for years. What were these gigantic conglomerates of galaxies like when the universe was just beginning to take shape? To understand this, we need to travel back in time to a period when the cosmos was much younger and more chaotic. Imagine a vast ocean of gas and cosmic dust. In this immense sea, small bubbles of matter begin to group together. These bubbles are the seeds of what would later become galaxies. At first, the universe was a very different place from what we know today. It was an environment filled with energy and activity, where the first particles came together to create the first atoms. In this context, galactic clusters began to form as dense regions where gravity started to play a fundamental role. As the universe expanded, these dense regions attracted more and more matter around them. Imagine a great gravitational pull, as if each cluster were a cosmic magnet attracting everything in its vicinity. At that time, dark matter, which forms a crucial part of the universe's structure, played an invisible but essential role. Although we cannot see it, its influence was and continues to be enormous, helping to shape galactic clusters from their beginnings. Over time, small groupings of galaxies began to merge and grow, forming larger clusters. Can you imagine what it would be like to see this from a distance? It would be like watching a game of dominoes where each piece pushes the next, creating a chain reaction. The mergers of galaxies not only increased the size of the clusters, but also altered their dynamics and structure. One of the most fascinating aspects of galactic clusters in their early stage is the diversity they presented. Not all were the same. Some were very rich in galaxies, while others were poorer and composed of fewer members. This phenomenon resembles different cities in the world. Some are bustling and full of life, while others are quieter and more solitary. The number of galaxies and their interactions within a cluster influenced its evolution over time. The interactions between galaxies in these early clusters were intense. With gravity as the protagonist, galaxies not only came together but also collided and merged. These collisions, filled with drama and energy, influenced the formation of new stars. Today, astronomers have concluded that many of the galactic clusters we see now formed from this dynamic activity in the past. But what about the stars we see in these clusters? In the early universe, star formation was an accelerated process. The interaction between galaxies and the abundance of hot, dense gas drove the creation of new stars at a dizzying pace. Every time two galaxies met, it was as if a spark ignited, leading to the creation of new generations of stars. Galactic clusters are not only important for the galaxies they contain, but they are also key to understanding the evolution of the universe. In their early stages, these clusters were like a kind of cosmic laboratory where the laws of gravity and structure formation were tested. Studying what they were like in the past helps us understand how the universe has changed over billions of years. However, it is important to keep in mind that these galactic clusters in the early universe were not static. Just like rivers that flow and change over time, clusters also evolved. The energy and matter within them were in constant motion, meaning their characteristics were not fixed. Each cluster was a living entity in continuous transformation. Modern telescopes have allowed scientists to observe some of these galactic clusters in the early stages of their existence. Through the light that reaches us from them, we can catch a glimpse of their history. But even with all the current technology, there are many questions that remain unanswered. The nature of the early universe continues to be a mystery, and galactic clusters are a key piece of that puzzle. Research continues, and each new discovery brings us closer to understanding how these gigantic groups of galaxies formed. Each cluster tells the story of its birth and growth. a narrative that speaks to the evolution of the cosmos as a whole. So when you look up at the sky and observe the stars, remember that behind each galactic cluster lies a dynamic and fascinating past that connects us to the origin of the universe. Finally, it is important to reflect on what all this means for us. Understanding galactic clusters in the early universe not only provides us with a glimpse into the history of the cosmos, but also helps us comprehend our place within it. Thus, every time we look at the stars, we are looking through time towards a past that has shaped the present and, possibly, the future of the universe. What if I told you that galaxy clusters have a fate that could be as fascinating as their very existence? Imagine for a moment that you are observing a vast ocean of stars and galaxies, where each galaxy cluster is like an island amidst that immensity. But what happens to these islands over time? Will they always remain where they are, or will they be affected by cosmic forces that change the landscape of the universe? Galaxy clusters, which harbor hundreds or thousands of galaxies, are not static entities. Since their formation, they have been in constant motion and evolution. As the universe expands, the clusters also move, but that's not all. Over time, these massive groups of galaxies can experience interactions that will change their future, as if they were pieces of a cosmic puzzle being rearranged. Can you imagine the chaos and beauty of these galactic collisions? The merging of galaxy clusters is one of the most impressive scenarios. When two clusters meet, it's as if two oceans collide, creating waves of galaxies that intertwine. These interactions can trigger the formation of new stars and modify the structure of the involved galaxies. But what does this mean for their ultimate fate? Perhaps some galaxies will become part of a new cluster, while others will remain isolated, like shipwrecks in a cosmic sea. However, the future of galaxy clusters is not limited to mergers. Over time, many clusters will eventually lose their cohesion. As the galaxies within them drift apart, the cluster may disintegrate, scattering its members across the vast universe. This process is similar to a group of friends gradually separating and venturing in different directions. Who knows where they will go? Dark matter, which makes up most of the mass of the clusters, plays a crucial role in this scenario. Its gravitational influence keeps the galaxies bound together, but it can also be responsible for some clusters disintegrating. When dark matter is redistributed or depleted, the balance is lost and the structure of the cluster is compromised. It's as if gravity is the invisible thread that binds a group of people, but when it breaks, it separates them forever. But what if we look even further ahead? In billions of years, the fate of galaxy clusters could be tied to the expansion of the universe. With the universe constantly expanding, many clusters will drift away from each other, and some may even be absorbed by the vast intergalactic void. This expansion could cause certain clusters to become lonely islands in a dark sea where galaxies recede at ever-increasing speeds. What will those galaxies feel as they watch their companions fade into the distance? As time progresses, galaxy clusters may also become the remnants of a universe that was once vibrant and full of life. Some scientists suggest that in a distant future, clusters could lose all their stellar activity, becoming inert structures where stars extinguish and space turns into an eternal silence. Can a galaxy cluster become a cosmic fossil, a testament to what once was? In this context, the life of galaxy clusters is a continuous cycle of creation and destruction. Although their ultimate fate may seem bleak, within every ending lies a new opportunity. Every interaction, every merger, and every disintegration is also a step toward the formation of new structures and new stars. Is it possible that in a distant future, the galaxy clusters we know today will transform into new spaces for life? Finally, the question we all ask is, how far away is that future? Although it may seem that the life of galaxy clusters stretches over eons, it is important to remember that the universe has its own rhythm, and what is bright and full of activity today may be just a shadow of what it once was tomorrow. However, this cosmic dance reminds us of the fragility and beauty of existence, even on scales as enormous as those of galaxy clusters. So, as we reflect on the fate of these majestic conglomerates of galaxies, let us remember that each cluster has its story, and each story is filled with unexpected twists and wonders to discover. The cosmos remains a mystery, and while we may not know for certain what the future holds for galaxy clusters, their journey is undoubtedly an essential part of the narrative of the universe. In the vast universe, some galaxy clusters stand out as true cosmic wonders. Did you know that there are clusters so large and bright that they can be observed even millions of light years away? Let's talk about some of the most famous galaxy clusters, those that have captured the attention of astronomers and curious minds alike. One of the most well-known is the Virgo cluster, a massive group that houses over 1,000 galaxies. This cluster is a cosmic giant located about 50 million light-years from Earth and is part of our galactic neighborhood. Imagine a neighborhood where the houses are so close to each other that they sometimes share the same garden. This is how galaxies behave within the Virgo cluster, interacting and sometimes even merging. This cluster is impressive not only for its size but also for its role in the dynamics of our own home, the Milky Way. Now let's move on to the Coma cluster, another colossal formation located about 380 million light-years away. This cluster is famous for hosting some of the brightest galaxies we know, such as the NGC 1404 galaxy. Looking towards the Coma cluster, one can feel like an explorer in a stellar ocean surrounded by bright islands. The density of galaxies here is remarkable, making it a fascinating place to study galactic growth and evolution. And we cannot forget the Perseus cluster, which is one of the most massive and brightest clusters known. Its splendor lies not only in the galaxies that compose it, but also in the halo of hot gas that surrounds it. This gas emits radiation in the form of X-rays, making it a prime object of study. Can you imagine observing a cluster that shines brightly in X-rays? It's like seeing a cosmic lighthouse in the darkness of space. Some galaxy clusters are truly unique. For example, the Abell 260 cluster, known for its elongated shape like a snake in space. This cluster shows us how interactions between galaxies can lead to unexpected structures. Galaxies are not static. They move, group together and transform, intertwining their fates in a cosmic dance that has been ongoing for billions of years. An interesting phenomenon occurs with the Hydra cluster, which hosts a unique mix of elliptical and spiral galaxies. This diversity offers us clues about the history of galaxy formation. The ellipticals are like wise grandmothers, having stopped forming new stars, while the spirals are young and vibrant, full of activity. The interaction between these different generations of galaxies tells a story of cosmic evolution. What about galaxy clusters that are colliding? The El Gordo cluster is a fascinating example. This cluster, located more than 7 billion light-years away, is the most massive we have found so far. Inside it, a titanic collision between two galaxy clusters is occurring, creating an explosion of energy and light. It's like watching two freight trains collide, a catastrophe that results in the creation of new stars and structures in the universe. Observing these clusters not only gives us a glimpse of their beauty, but also helps us better understand dark matter and the energy of the universe. Each of these clusters acts as a cosmic laboratory, where scientists can study how matter groups together and how it evolves over time. The way galaxies are distributed and move within them reveals secrets about the history of the universe. Galaxy clusters also play a crucial role in the formation of new stars. In places where the density of gas and dust is high, gravitational forces can cause material to collapse and form new stars. It's an endless cycle, where the death of old galaxies gives way to the birth of new ones. In this sense, clusters are like stellar factories, constantly producing new stars that will illuminate the universe for billions of years to come. The rich diversity of galaxy clusters also offers us a glimpse into the different environments in which galaxies can live. Some clusters are abundant in dark matter, while others seem to be lighter. These differences can influence the fate of the galaxies that inhabit them, and understanding this is key to unraveling the mysteries of cosmology. By observing galaxy clusters, astronomers can also identify patterns that reveal the history of the universe. Each cluster is like an open book, telling a story of collisions, mergers, and the influence of dark matter over time. Who knows how many stories are still waiting to be told in these magnificent groups of galaxies? In conclusion, galaxy clusters are not just groupings of stars. They are monuments of cosmic history that offer us a window into the past, present, and future of the universe. From the Virgo cluster to El Gordo, each of them has something unique to tell, so the next time you look up at the starry sky, remember that out there, in the vastness of the cosmos, there are countless galaxy clusters waiting to be discovered, each with its own story to tell. In the vast ocean of space, where galaxies float like islands in the immensity, there exists a fascinating phenomenon, cosmic radiation. But what is this radiation really, and how does it affect galaxy clusters? Imagine you are on a beach, feeling the warmth of the sun on your skin. That energy you feel is similar to the radiation coming from stars and other cosmic events. But here, in space, that heat not only warms, but can also have a profound impact on the formation and evolution of galaxies. When talking about galaxy clusters, it is essential to understand that they are not alone in the universe. They are surrounded by a kind of cosmic soup composed of radiation of all kinds. This radiation, which includes high-energy particles and photons, can influence how the galaxies within a cluster behave. Think of it as a kind of galactic weather where conditions can change from day to day, affecting the internal dynamics of these enormous structures. What type of radiation are we considering? The cosmic background radiation, for example, is like the echo of the Big Bang, the remnant of the energy that gave rise to our universe. This radiation is omnipresent and can be detected in every corner of the cosmos. However, there are other types of radiation, such as supernova explosions and gamma-ray bursts, which are much more intense and can alter the environment of galaxy clusters in surprising ways. An intriguing aspect of cosmic radiation is its ability to ionize the gas found in clusters. When high-energy particles collide with gas atoms, they strip away electrons, creating a plasma state. This process is not simply an isolated phenomenon. It has significant repercussions for the formation of new stars. If the gas becomes ionized, it may lose its ability to cool and collapse, meaning that star formation is affected. Radiation can also influence the movement of galaxies within a cluster. Imagine each galaxy as a ship in a turbulent ocean. Cosmic radiation acts like the wind that can push these ships in different directions, altering their trajectories and in some cases even causing collisions. These interactions can be responsible for galactic mergers, a process that, although violent, can also lead to the formation of new galaxies. Within galaxy clusters, radiation also plays a crucial role in the distribution of dark matter. This matter, which we cannot see directly, interacts with radiation in complex ways. By studying how radiation affects dark matter in a cluster, astronomers can gain clues about the structure and evolution of the universe as a whole. It is like a cosmic puzzle where each piece is a galaxy, and radiation is the thread that connects everything. Cosmic radiation can also contribute to the creation of supermassive black holes at the center of some clusters. These cosmic monsters can attract matter around them, and the radiation they emit can have devastating effects on their environment. The interaction between radiation and material in a cluster can lead to the creation of particle jets that propagate at speeds close to light, further altering the dynamics of the cluster. But what about the impact of radiation on life in the universe? As galaxy clusters are affected by this radiation, they also influence the environment in which stellar systems capable of harboring life might exist. The conditions that create a suitable place for life are delicate and can be altered by cosmic radiation. This cosmic dance between radiation, matter, and galaxies can mean the difference between a fertile place and a stellar desert. Despite all that we know, there are still many mysteries to solve. The relationship between cosmic radiation and galaxy clusters is an active field of study, full of intriguing questions. For example, how will radiation behave in galaxy clusters in the future? Will it play a role in the formation of new structures as the universe continues to expand? The study of these phenomena not only helps us understand the present, but also offers a glimpse into the future of our universe. Finally, we must not forget that cosmic radiation is just one aspect of the vast and complex web that makes up galaxy clusters. Each discovery leads to new questions, and each question brings us a little closer to understanding our place in the cosmos. So the next time you look at the stars, remember that you are observing a universe full of dynamic interactions, where cosmic radiation plays a fundamental role in the history of galaxies and potentially of life itself. Exploring these topics is not only fascinating but also connects us to the vast mystery of the universe. Have you ever looked at the stars and wondered if there is life out there in those distant star systems? The answer to that question may be closer than you think, and an important part of this puzzle lies in galaxy clusters. But how can these colossal groupings of galaxies influence the possibility of life? Galaxy clusters are like large cities in the vast universe. Imagine a metropolis filled with buildings, each representing a galaxy, where the interactions between them can be compared to the social relationships of their inhabitants. In this sense, the way galaxies within a cluster interact can have repercussions on the formation of new stars, which are key to the existence of planetary systems and ultimately life. The formation of new stars is essential for the development of systems that could harbor life. In galaxy clusters, gases and dust concentrate and collapse due to gravity. But what happens when several galaxies come together? This encounter can cause the gas to cool and condense more quickly, creating new stars at an accelerated rate. Thus, a galaxy cluster becomes a true incubator for stars. Now, what about dark matter? Although we cannot see it, we know it is there, and it plays a crucial role in the formation of structures in the universe, including galaxy clusters. Imagine dark matter as an invisible fabric that holds together the complex structure of the cosmos. Without it, the gravity of the galaxies would not be enough to keep them bound together in clusters. But how does this affect life? Galaxy clusters, being the place where so many stars are born, also become the home of elements necessary for life, such as carbon and oxygen. As stars die, they release these elements into space, enriching the interstellar medium and providing the basic components for new planets to form, and potentially life. The interaction between galaxies within a cluster can also be fascinating. When two galaxies collide, they not only merge but also trigger a wave of star formation. This phenomenon can be seen as a galactic rebirth. In this sense, life may be the result of cycles of creation and destruction, where interactions in galaxy clusters play a fundamental role. Some theories suggest that galaxy clusters may also act as mechanisms for transporting life. Material expelled from galaxies in supernova explosions can be transported through the intergalactic medium and eventually reach other systems. This raises an intriguing question. Could galaxy clusters be responsible for seeding life in other corners of the universe? Moreover, the proximity of galaxies in a cluster can facilitate the transfer of matter and energy. This means that in such a dynamic environment, conditions could be suitable for developing environments conducive to life. For example, the heat generated by interactions between galaxies can create zones where planets have warmer and perhaps habitable conditions. However, it is not all that simple. The conditions in certain galaxy clusters can be hostile to life. Cosmic radiation and extreme gravitational forces can make some places inhospitable. This contrast between the environments of galaxy clusters leads us to wonder, is life a common or rare phenomenon in the universe? The search for life in other star systems focuses on planets orbiting stars similar to our Sun, but wouldn't it be fascinating to consider that life could arise in completely different conditions, in systems formed by stars born in galaxy clusters? This idea opens up endless possibilities about how and where life might exist in the cosmos. Scientists continue to explore the relationship between galaxy clusters and life. Through telescopes and space missions, data is being collected on star formation and the composition of clusters. Each new discovery brings us one step closer to understanding not only how the structures of the universe form, but also how these may influence the existence of life beyond our planet. The fascination with life in the universe leads us to reflect on our own existence. If galaxy clusters are incubators of stars and by extension of planetary systems, what other surprises does the vast cosmos hold for us? The quest for answers to these questions drives science forward, and each new finding could be another clue in the great puzzle of life in the universe. What is clear is that galaxy clusters are more than just simple groupings of galaxies. They are centers of cosmic activity that may help answer humanity's biggest questions. Are we alone in the universe? How did life form on Earth, and could it have originated elsewhere? These questions resonate in every corner of the cosmos, and galaxy clusters could be the keys to unveiling their secrets. What relationship exists between galaxy clusters and string theory? It may seem like a distant question, almost as if we were talking about two different worlds, but in the vast web of the cosmos, everything is interconnected. String theory, for its part, is one of the most intriguing and complex proposals that physicists have developed to understand the fundamental nature of the universe. But how can something as abstract as string theory be linked to those gigantic groupings of galaxies that shape our cosmic existence? To begin with, let's think about the structure of the universe. Galaxy clusters are like enormous islands in a dark ocean. These islands are formed by galaxies that attract each other through gravity. But what about the fabric that connects all of this? This is where string theory comes into play. This theory suggests that what we know as subatomic particles are not just tiny points, but are actually vibrating strings. Just as the strings of a violin produce different notes depending on how they vibrate, these strings could give rise to different particles and forces that shape our universe. Now, how does this relate to galaxy clusters? Imagine that each string in this theory is capable of influencing the matter and energy around it. The interactions between these strings at a fundamental level could affect the way galaxies group and behave within a cluster. This suggests that, in a profound sense, the structure of the cosmos, from galaxy clusters to the smallest particles, is governed by the same fundamental laws. It is fascinating to think that as scientists study the dynamics of galaxy clusters, they might also be unraveling the secrets of string theory. What if the way galaxies move and group provides clues about the nature of these strings? The vibrations of the strings could influence how dark matter is distributed, which plays a fundamental role in the formation of galaxy clusters. Dark matter, that mysterious substance that we cannot see but know is there, could be a manifestation of the properties of the strings. Let's think of dark matter as the invisible glue that holds galaxies together within a cluster. If strings influence the properties of dark matter, then studying it could open new avenues in understanding how and why those enormous groups of galaxies form. An intriguing aspect of string theory is that within it, space and time are not immutable. They become flexible entities shaped by the interactions of the strings. This raises a fascinating question. Could the behavior of galaxy clusters also be a manifestation of this flexibility? If space is malleable, then perhaps galaxy clusters not only move through it but also shape it, creating an impact on the large-scale structure of the universe. With each new discovery in astronomy and physics, more questions arise. Could galaxy clusters be natural laboratories for studying string theory? Astronomers are constantly looking for patterns in the distribution of clusters that could reveal information about the structure of space-time. The connection between what we see in the sky and what occurs at deeper levels of matter is a puzzle that continues to challenge our understanding. Moreover, the study of galaxy clusters could offer clues about the nature of gravity itself, which is one of the central aspects of string theory. If we understand how galaxies group and behave within a cluster, we could unravel the mysteries of quantum gravity, an area where string theory seeks to unify gravity with the other fundamental forces of the universe. Some scientists venture to think that through the investigation of galaxy clusters, we could not only better understand our cosmic history, but also glimpse the future of the universe. If string theory manages to describe reality in an accurate way, we could be on the cusp of a revolution in our understanding of everything from dark matter to the formation of galaxy clusters. The search for answers at the intersection of cosmology and string theory is an exciting journey. Each new finding in the study of galaxy clusters could be a clue that brings us closer to understanding not only how our universe was formed, but also how it functions at its deepest level. Thus, in this cosmic dance, galaxy clusters and strings intertwine in a fabric of mystery where each thread tells a part of the story of the cosmos. As we advance in our quest for knowledge, it is essential to remember that each answer leads us to new questions. String theory remains a field full of unknowns, but every discovery we make about galaxy clusters can be a step toward unraveling the complexities of reality. The exploration of the relationship between these cosmic giants and strings is not only a scientific pursuit but also an adventure that connects us with the universe as a whole, reminding us of how little we know and how vast the mystery that surrounds us is. Galaxy clusters are true giants of the universe, but despite their majesty, many aspects remain shrouded in mystery. Why are they so important yet so poorly understood? Science has advanced significantly, but there are still questions that leave us perplexed. What really happens inside these colossal groupings of galaxies? There are many unknowns that invite us to explore further. One of the most intriguing mysteries is the nature of dark matter. We know it is fundamental to the structure of the universe, but what exactly is it? Although it is estimated that more than 90% of the matter in the universe is dark, its essence remains a puzzle. Scientists are trying to unravel how this invisible matter affects the formation and dynamics of galaxy clusters. Could it be that without dark matter, these clusters would not exist at all? Another enigma that fascinates us is the role of supermassive black holes at the center of some galaxy clusters. How is it possible that these monsters devour everything around them while also influencing the evolution of their cluster? There are theories suggesting that these black holes could be related to the formation of new stars. Could it be that, despite their destructive nature, they are also agents of creation in the cosmos? The evolution of galaxy clusters over time is another topic that sparks curiosity. How have they changed from their beginnings to the present? Astronomers have observed that many clusters have gone through phases of intense activity where interactions between galaxies have triggered episodes of star formation. However, what will happen to them in the future? The possibility of merging with other clusters is one of the most discussed theories. When discussing star formation, an intriguing question arises: what role do galaxy clusters play in the creation of new stars? It has been shown that the density of matter in clusters can be a catalyst for star birth. But what factors determine whether a star will be born in a cluster or remain in the limbo of space? The relationship between galaxy clusters and life is another fascinating mystery. If galaxy clusters are like large factories for stars, could they also influence the possibility of life on other worlds? Could it be that some clusters have conditions suitable for hosting planetary systems capable of supporting life? The questions are so numerous that they lead us to reflect on our place in the universe. One aspect that is often overlooked is the impact of cosmic radiation on galaxy clusters. This radiation, which originates from cataclysmic events such as supernova explosions and black hole activity, can alter the dynamics of the clusters. How does this radiation affect star formation and the evolution of galaxies within a cluster? As we explore these mysteries, we also encounter string theory, which suggests that the universe could be much more complex than we imagine. Could this theory offer answers to questions about the structure of galaxy clusters and the nature of gravity? The interconnection between particle physics and cosmology is an emerging field of study that promises to unveil secrets of the universe. However, despite all we have learned, there are still many unanswered questions that invite us to continue investigating. What happens to galaxy clusters that collide? How do they reconfigure, and what effects do they have on their galaxies? These collisions can trigger complex processes that could lead to the formation of new galactic structures. The search for answers does not end here. There are other phenomena, such as dark matter filaments, that could be connecting galaxy clusters to each other. What implications would this have for our understanding of the universe on a large scale? The possibility of an invisible network connecting these giants is both intriguing and perplexing. Finally, looking to the future, the exploration of galaxy clusters presents a unique opportunity to learn more about the universe. Technology is advancing rapidly, and with it, our ability to observe and understand these colossal groupings. What discoveries await us in the coming years? Human curiosity and the passion for knowledge are the forces that drive us to continue probing the secrets of the cosmos. Each new finding brings us one step closer to answering the questions that have kept us awake for so long. Galaxy clusters, with their immense power and mystery, continue to be a fertile area for research. So as we gaze at the starry sky, let us remember that each point of light could be hiding a riddle waiting to be uncovered. Are we ready to unravel the secrets of the universe? The adventure is just beginning. The vastness of the universe and the complexity of galaxy clusters lead us to reflect on their meaning. What do they tell us about the cosmos we live in? Each cluster is like a huge city of galaxies, a meeting point of billions of stars that have been traveling together for eons. In this vast cosmic network, every element tells a story, and it is precisely that narrative that helps us understand our own existence. Galaxy clusters are not just groupings of galaxies, they are dynamic communities that interact, merge, and evolve. Have you ever wondered how these interactions shape the fate of individual galaxies and ultimately that of the universe? The answer lies in the gravitational forces and dark matter that act as the invisible glue holding these vast collections of galaxies together. Without dark matter, these clusters would not exist as we know them. It is interesting to think that galaxy clusters are not static. Imagine a cosmic dance where galaxies spin and glide around each other. Some even collide and merge, creating new stars in the process. Isn't it fascinating to think that in this vast stage, galaxies are constantly changing and evolving? This cosmic dance is a reminder that the universe is in a state of constant transformation. The formation of new stellar systems in these clusters is another crucial aspect. Did you know that amidst all that interaction, conditions can be perfect for new stars to form? As galaxies approach each other, gas and dust are compressed, which can trigger a burst of stellar activity. It's as if each cluster becomes a star factory, where the right conditions can give rise to new luminaries in the sky. Galaxy clusters also play a fundamental role in the evolution of the universe. How do they influence the expansion and overall structure of the cosmos? By studying how they group and distribute, astronomers can unravel the secrets of dark energy and the accelerated expansion of the universe. Each cluster is like a brick in the vast cosmic construction, and their study helps us understand what shape the universe takes and where it is headed. So what happens when we look up at the sky and observe these clusters? We are looking into the past, into the history of the universe itself. Each cluster is a record of events that have occurred over billions of years. What mysteries do they reveal to us? Every observation we make brings us closer to answers about how the universe formed and what its ultimate fate is. You might be wondering what remains to be discovered in this field. Although we have learned a lot, there are still unanswered questions. What about dark matter and its relationship with cluster formation? How does cosmic radiation interact with them? Research continues, and each new discovery takes us deeper into the mysteries of the universe. The importance of galaxy clusters extends beyond astronomy. How do they relate to the possibility of life in other stellar systems? The way stars form and evolve in these clusters can influence the creation of conditions suitable for life. Each new finding could have profound implications for our understanding of life in the cosmos. As we look to the future, it is exciting to think about the fate of these clusters. Will they merge, disperse, or disintegrate over time? The evolution of galaxy clusters is a fascinating topic that invites us to speculate about the future of the universe. What new formations and transformations await us as time progresses? Galaxy clusters are also a fertile ground for string theory and other innovative ideas in physics. How do these theories relate to the structure of the universe and the very nature of reality? The quest for answers to these questions is a testament to human ingenuity and our innate curiosity to understand the unknown. In concluding this exploration, it is essential to remember that each galaxy cluster we observe is a reminder of how vast and mysterious our universe is. Each new discovery carries with it the promise of new questions, and it is in that pursuit of knowledge where the true beauty of science resides. Astronomy, like the universe itself, is in constant expansion, and galaxy clusters are protagonists in this story. So the next time you look at the starry sky, remember that you are not just seeing distant lights, you are witnessing cosmic history. With each galaxy cluster, we are one step closer to unraveling the secrets of the universe. Curiosity should never cease, and the quest for knowledge about galaxy clusters and their significance in the grand scheme of the cosmos is a journey that has only just begun. The story of the universe is told through them, and we are the narrators of this infinite narrative.